There we go. Number 1 is Fermi, F-E-R-M-I. 2 is Roentgen for X-rays. Becquerel for uranium being radioactive. Marie and Pierre Curie together, Nobel Prize for radium. Marie Curie, Nobel Prize for polonium. And then our first of 17 bonus points is that Marie is the first woman to win and the only 2-time winner of any gender. 10 changes composition of nucleus. 11 spontaneous emissions accompanying a change in nucleus. 12 is neutrons. 13 to 30 is a slight miscount. If I number 13 to 30, it should be 18 real points, and it's actually 19 real points. So I actually didn't need that number 100, but oh well, it happened. I'll just kick a free point your way because I apparently can't count to 18. But this group, we have alpha with the sideways fishy. That's positive. That's low penetrating power. Paper could stop it. High danger level. 42He was the symbol, and it ionizes gases. That's like the 19th point that I must have maybe not counted, because it said, tell one other fact about one of them. Ionizes gases is that fact. Beta is the bee with the long tail on its back. That's negative. It's medium for aluminum foil stopping it, hence the Weird Al clip that day. Medium danger, and 0 -1 with a little e. Gamma is the little fishy headed downstream. That's neutral. It's high, lead or concrete to stop it, but low danger level, and it has no mass or charge. And that's the base 19 points. Something like that. Then for the 5Es, we have, I guess one of those we already encountered because of my misnumbering. But you can inhale it, and that causes trouble for alphas. Smoke detector usage is alphas. To say that the atomic number counts the protons and the mass number counts protons and neutrons, and therefore that 42He has 2 protons, 2 neutrons. A little bit of an essay question around the 42He will get you. Atomic number counts protons. Mass number counts protons plus neutrons. And on that 42He zone is where I'm doing this description. That one would therefore have 2 protons, 2 neutrons. Beta extra credit thing is that it gets produced when a neutron becomes a proton. So that's our 5Es. Neutron becomes proton. That's where beta comes from. It's kind of like the counterweight to that. Chemistry is a lot like math. Everything needs to be paid for. Whatever you do to one side, do to the other. Kind of algebraic idea there. The beta is the compensation for neutrons turning into protons. There has to be a payment made.
Was there anything more for alpha than can inhale and use to increase smoke detectors? Was that all?
No, that's 2 different ones. So
Yeah,
can be inhaled and make trouble for you. Smoke detectors, that whole thing about the atomic numbers, mass numbers,
Okay.
that was all alpha club. And then beta is that neutron becoming proton thing. And then the 5th E is just because I can't count. Up to 30. 31's natural radioactivity. 32 is radiation sickness. 33 is changing a radioactive element into another element, which might or might not be radioactive, but you don't have to say that last phrase. Radioactive decay, series of changes undergone by radioactive substances until they become stable. 36, either say it's not radioactive or it doesn't emit radiation, whatever you like. Rutherford with a bonus point of you're bombarding things with high energy particles, and most of them miss, but you just need one hit. Accelerate charged particles is cyclotron, and the bonus point there is that it's based on the concept that unlike charges attract and like repel, and that's how they're doing their game there. Question front. Okay. 39 on the new page. Wait. Want me to run something back or wait a bit? Yeah.
What was the extra credit for 37?
You bombard stuff with high energy particles, and most of them miss, but you only need one hit to get a
And then
transmutation.
like charges repel. on
Like
the track.
repel, unlike charges attract. Yes.
Oh, I didn't hear that one. You say bombard with fast.
37, we're bombarding things with high energy particles. That's what Rutherford is trying to do. Most of them miss, but you just need one hit. It's kind of like hitting the tiniest bullseye with the tiniest dart. It's not that easy. So almost every particle that he's firing at stuff is missing, but one hit will do the trick. More to 38, anything front side? Middle page. We have radioactivity from a substance not found in nature. Positive electron. Nucleus grabbing an electron, and that converts a proton into a neutron. Transuranium, and then synthetic. That would be a sample of a kind of question that from sheet to sheet I might switch them up to just make sure you're paying attention. But transuranium is above 92 because that's where uranium lives, and I'd give you a table so that could help also to remind you of that fact. Synthetic is just anything man-made. Anywhere, doesn't matter what number it is. 44 to 8 feels like a question I'd also probably scramble all kind of orders up on, but proton is 1, 1 with a capital H for hydrogen. Neutron is 1, 0, little n. Then 2, 1, big H. Then 3, 1, big H. Then 0 plus 1, little e. And you have to know those really pretty well to do the problem page of the practice test and test. 49 is the time for half of a radioactive mass to decay. Nothing. Fractions of seconds up to billions of years. No, they turn into other things. Then Geiger counters and another bonus. Bonus on Geiger counters is that the particles ionize the gas and a current flows that makes a clicker go click. So particles ionize gas, there's a current flows then that makes a clicker go click. 54, that would feel like another switch it up kind of question possibly. But Curie is the old one. That's big C, little I, and that's the number 3.7 times 10 to the 10th disintegrations per second. 57, Becquerel is the new one. That's big B, little q. That's 1 disintegration per second. And then bonus point in that Curie zone, bunch of stuff, like a triple fact. 1 Curie is a lot. 3 Mile Island had 2.5 million Curies of xenon, and Mount St. Helens was 3 million Curies of radon.
Wait, what?
1 Curie is a lot. 3 Mile Island is 2.5 million Curies of xenon. Xenon. And Mount St. Helens was 3 million Curies of radon. Spoiler alert, don't live near an active volcano.
What?
Yeah.
Because that's ended well for people.
Yeah.
Darn. Really planning on teaching.
It was okay in Rome. I think Vesuvius, that wasn't a problem at all, was it?
What about Pompeii? Oh well.
That was in Rome.
Pompeii's real?
Yeah.
Really?
60 to 67.
Yeah, that's what Mount Vesuvius.
I'm sorry. It
That's
took me a
not-
second to get the joke.
That's not Vesuvius.
Yeah, because Pompeii is the city, Mount Vesuvius was the mountain.
Learning all kind of stuff today.
Same thing.
We're expanding our minds. Radioactive dating is a category. Medical imaging was a category. Radio labeling in genetic testing is a category. Irradiation of produce was a category. Quickest answer was for the radio labeling in genetic testing. That was just to say tracking DNA. Medical imaging had like a double answer. You inject radioactive stuff and use x-rays to take pictures. Bonus point there, technetium, Technetium. That's the main thing that they inject into you.
What was it?
Technetium is the main thing that gets injected in terms of commonality. Technetium, most common radioactive thing that gets injected into people for medical imaging. Irradiation of produce is going to keep food for a long time without spoiling, and we're trying to inhibit or get rid of, or some sort of negative kind of verb for items: bacteria, fungi is the plural, insect eggs, larvae, if you want to pluralize that, larvae. Radioactive dating is the longest answer, but with a bonus backup. Radioactive dating is that the ratio of C14 to C12 is constant in living things, believed to be constant over time, but C14 decays. And then the bonus backup is that uranium can be used to date non-living things like rocks or dirt or whatever. I'll pause there, that was a lot. Anything recapping? 68 is splitting a nucleus to give 2 plus energy plus neutrons. So splitting one nucleus to get 2 plus some energy plus some neutrons. Chain reactions, a self-sustaining reaction where a product is one of the reactants. Critical mass is the minimum amount of radioactive substance necessary to maintain the chain reaction. 71, bonus point for Meitner, last name being the person who got chucked out of Germany by Hitler.
What was the name?
Meitner, Meitner. Lisa was her first name, if you care about that, Lise. But the explanation is that one of the 3 scientists was a Jew, and Hitler forced her out of the country and threw away the research as Jewish tainted.
AKA racist.
Yeah, good thing Hitler was a racist. At least in this one circumstance.
Singular circumstance.
Because a Hitler with an atomic bomb would have not been a very good Hitler.
At least Hitler was racist to her.
To her. And
71. 72 is Szilard, Szilard, and our friend Einstein. It's E before I twice in his name, Einstein. Extra credit is that Bohr, Bohr, was the middleman who connected Meitner to Szilard. So Meitner, out of Germany by Hitler's racism, knows Bohr somehow. Bohr connects her to Szilard. Szilard thinks, oh my goodness, we can't let the Germans do this, and got Einstein to sign that letter, and the rest is history, literally. 73, FDR, Manhattan Project, New Mexico, 1945, Truman, Hiroshima, 3 days later, Nagasaki, 2 or more nuclei combining to form a heavier one, mass in exchange for energy. 83 is heat. Trivia question, extra credit point. The sun is 20 million degrees Celsius. 84 is fission. Extra credit point is that those bombs are 15 times the energy of the A bombs, and there were 50,000 of them existed when the book that we're reading was written.
What was that?
15 times the energy of the A bomb, and 50,000 of those warheads existed for our book.
50,000?
50,000. 85 is a nuclear fission reactor, a turbine and generator, and a condenser. Last bonus point of the collection is since 1957, that's 16% of our power.
1957?
1957, 16% since then. 88 is a cadmium rod and water. 89 is that the uranium-235 is only 2 to 3%, and in a bomb it's 90%. Four problems are thermal pollution in rivers, risk of accidents, theft of fissionable material, and disposing the waste. Everybody's in favor of the waste being disposed of at some remote location, except the people that live near the remote location. So most of America is kind of like, yeah, why don't we just bury that stuff in New Mexico? There's nothing there. And all the people in New Mexico are like, no, pass on that. And even if they get the people in New Mexico bribed off, that still has to travel somehow through other people's states, and then those people freak out. So if you have like a nuclear plant in Pennsylvania and you've got to like ship that stuff out to New Mexico, nobody in between is really too happy about that traveling through their neighborhood. So that's just a hassle every which way. 94, we got 3 Mile Island, 1979. We have Chernobyl, 1986. 98 is naturally occurring. 99 leaves polonium trapped in your lungs, and the radiation from the polonium can cause tumors. And then 100, you could say pretty much literally anything other than leave it blank. It doesn't really matter to me. Some of you, I think, have artwork planned. Other people might have a feeling of essays. Some people might simply say no. Or maybe you've lost it by the end of this and you're coming a little bit unhinged and you actually say yes because you
At
pleasure,
least this isn't.
I'll pray for you.
pleasure turned into pain maybe at some point there. I don't know.
Whoever says yes.
Was that like Stockholm syndrome?
Yeah.
You start to like enjoy the quiz.
We will pray for you.
Question any of that vocab?
What was the bonus point on how hot the sun is?
20 million degrees Celsius. Anybody else? Questions or side trivia facts?
What was 81?
81 is mass exchanged for energy. E equals mc squared in effect. Anybody else? Stop that.